Ah, the Java string. It's probably the very first class any of us ever touched. I mean, it's so common, it feels like it's just built right into the language. But that familiarity, it can be a little deceptive. Today, we're going to pull back that curtain and really dig into the mechanics that make the difference between a good Java coder and a great one. So think about it. You probably write a line of code just like this dozens of times a day, right? You don't even think about it. But what is Java actually doing in the background? Where does that string even live in memory? And why does it sometimes act in ways you just don't expect? Answering these questions, well, that's the key to writing some seriously efficient, bug-free code. Everything, and I mean everything, starts with one single core idea. It's a non-negotiable principle that pretty much dictates everything else we're about to talk about. This is what we call the immutable truth of the Java string. This right here is the golden rule. Once a string object is created, its value is set in stone. It cannot be changed. So when you think you're modifying a string, like you're trimming it or adding to it, you're not. What's really happening is you're creating a brand new, completely separate string object every single time. And getting your head around this is absolutely crucial because it has huge implications for performance, memory, and even security. Okay, so if we're constantly making new objects, you're probably thinking, wait, isn't that incredibly inefficient? And it would be. But Java has this really clever optimization that comes directly from this whole immutability thing. It's a special little area in memory called the string constant pool. And this is a lifesaver in big applications where you see the same text again and again. Think status codes, user roles, that kind of thing. The pool makes sure those duplicates only ever exist once in memory. Now, this slide shows two totally different ways to get to the same result. On the left, when you create a string with quotes, that's called a literal. Java's being smart here. It first checks the string pool. If the string test is already in there, it just points your new variable right to it. No wasted memory. But on the right, when you use the new keyword, you're basically telling Java, hey, I don't care about the pool. I want you to create a brand new object on the main memory heap, no matter what. All right, so let's shift gears from theory to practice. Let's look at the tools you use every day and some of the common traps people fall into, where really understanding what's going on under the hood starts to make a big difference. And this brings us to a classic bug that gets so many developers. The double equals operator. All it does is check the memory address. It's basically asking, are these two variables pointing to the very same spot in memory? But the dot equals method asks a totally different question. It says, I don't care where they are. Do these two strings hold the exact same sequence of characters? So remember, if you want to know if two strings have the same value, you have got to use dot equals. Oh man, we've all been here, right? You're looping through a big list of data, maybe building a CSV file or some JSON, and your whole application just slows to a crawl. The UI freezes up. What on earth is going on? Well, the answer goes all the way back to that golden rule we just talked about. And here's the culprit. This is the high price you pay for immutability when you're not careful. If you're in a loop and you're using the plus sign to add to a string, say 1,000 times, you are literally telling Java to create and then throw away 1,000 temporary string objects. Each one gets created, used for a split second, and then marked for garbage collection. It is a massive, massive drain on your system's memory and CPU. Thankfully, this is a totally avoidable problem. Java gives us much better tools for this exact job. So let's talk about how to build strings the right way so you never fall into that nasty concatenation trap ever again. This little table breaks it all down. See, unlike the string class, string builder and string farber are mutable. They're designed to be changed. Now, for 99% of what you'll be doing, just building a string inside a single method, String Builder is your absolute champion. It is wicked fast because it doesn't have the overhead that String Farber has to deal with for thread safety. And using it is just this simple. It's a 3-step pattern. First, you create one String Builder object before the loop even starts. Second, inside the loop, you use the super efficient .append method over and over again. And finally, only when you're completely done, you call .toString just once to get your final finished string. This is clean, it's fast, and it's a real sign of a professional Java developer. All right, let's peek at some of the more advanced stuff. These are the tools you might not need every single day, but knowing they're there can help you solve some really specific, really tricky problems when they pop up. So remember that string pool? Well, the .intern method is like your manual control stick. Let's say you have a string that you got from a file or a database, so it's living on the heap.
If you think you might have thousands of duplicates of that string, you can call .intern on it. What it does is it checks the pool to see if an identical string is already there. If it finds one, your heap object gets tossed, and you get back the shared one from the pool. It can be a huge memory saver, but you gotta use it carefully because that lookup process has its own little performance cost.
And here's a quick pro tip for you. Dot equals is perfect for comparing things like database IDs, but it knows nothing about human language. For example, in German, the word Straße and the one with the schwas character, well, they should often be treated as the same. The collator class is smart about language. It knows those kinds of rules for different regions. So for any app that needs to work around the world, this is absolutely essential. So wow, we've covered a ton of ground, huh? From the core principles all the way to some pretty advanced techniques. Let's just boil it all down to the absolute essentials, the rules you should just carry with you in your head every single day. This is it. This is your cheat sheet. Just burn these into your brain. Number 1, always use dot equals to compare what's inside a string. 2, always use string builder when you're building up strings inside a loop. 3, never forget that strings are immutable. And 4, really understand the difference between the efficient string pool and forcing a new object on the heap. Oh, and of course, always be careful about nulls. Mastering these will save you from so many headaches, I promise. And that really is the main idea here, isn't it? The Java string isn't just some simple little thing. It's a precision tool. And taking the time to really understand how it works, its strengths, and its weaknesses, that's an investment that is going to pay off for your entire career. So I'll just leave you with this question. We've seen just how much is going on beneath the surface of something as simple as a string. It really makes you wonder, right? What other everyday pieces of your code, your lists, your maps, those basic for loops, are hiding their own secrets that, if you just understood them a little better, could completely level up your skills as a developer?